Hi, hello friends. Myself Rakeshar. We at Emertxe Information Technology done an internship, and our project is on car black box. And we are from BMS Institute of Technology and Management College. And myself Rakeshar and my colleague Girish will continue the rest of the project.
I'm Girish. I'll give some brief introduction about the car black box project. It's like it's physically installed in the car or downloaded as a smartphone app. It like to links to a GPS device that measures and records the vehicle speed, location, and distance traveled, and taking as a driver's frequency and time to of the day in the car motion, and is also known as event data or a accident data recorder. And let me look up to the simulation requirement part. That's we required a MPML lab, XAD software, and a XE8 compiler, and PicSimlab pick, and CST and MPA, and timer to under access switch. Let me come to the first basic topic. What is a embedded system? Embedded system is a combination of a computer hardware and software designed for a specific function. Embedded system may also function within a larger range. The system can be programmable or have a fixed functionality. Types of embedded system, that's like a we have four types. That's the standalone, real-time system, and the networked and the mobile. And the advantages of our project, the car black box, it's a real easy to extract the data, easy to analyze the required data. It will not affect the privacy of the driver. Helpful to the car manufacturer to improve the car design, and helps to investigate the team. And it's connected to even to the GPS system. So it even can, in turn, it can even help the insurance company. Let me look up to the parts of microcontrollers and microsensors, microprocessor. Microcontroller is an integrated circuit which is capable of being programmed to perform specific tasks. It has a design restrictions such as a memory size, input capacity. Choose a memory control based on your application and a peripheral functions, performance and price availability of the tools and special capabilities. And a microprocessor is used in a personal computer, whereas microcontroller is used in an embedded system. That's the thing. That's a microcontroller which we are using in our embedded system. And because a microprocessor consists of a central processing unit, and where microcontroller consists of CPU, memory, and input and output, in all the it all these all things are integrated into a single chip. This is a microcontroller, and a microprocessor uses an extra bus to interface to a RAM, ROM, and the other peripherals. On the other hand, microcontroller use an internal controlling bus. Microprocessor based on a non-Venom model, but microcontrollers are based on Harvard architecture. Microcontrollers, like all the components will be in a single chip, and it will be less flexible because we can't use and reliably, and less design complexity. Well, in other terms, microprocessor, all the components are assembled separately, more flexible and more design complexity. And it's quite complicated and expensive with a large number of instructions to the processor. But the microcontroller is inexpensive and straightforward, which are all integrated into a single chip. This is a PicSimlab architecture where we can see GPIO and 12C and ADC, and these are the other output resistors. RS2C32 LEDs that's used for the displaying buzzer to indicate whether the program is completed. Whenever the task is completed, it gives an a buzzer, and the digital keypad of 16 to 4 LCD type and SSD, and the matrix keypad and CLCD. And the PicSimlab, this is software in which we are stimulating our car black box project. It's a real-time emulator of development boards with integrated MPLAB and AVR GVD debuggers. As a purpose, PicSimlab is used to emulate a real hardware, and it does not have any source editing support. For source editing and debugging tools, we use real boards should be used in the PicSimlab, such as MPLX Lab or Arduino IDE. PicSimlab have integration with MPLAB, Arduino IDE for programming the board's controllers. This is the LCD where we can see the display. It's like a character liquid crystal. This can be of two types, like a 16 into 2, and this the picture we can see here is 16 into 4 display. It displays all the ASCII characters and some special character. It mostly used of two types communication, like 4-bit or 8-bit mode. Rakesh will continue about NKP.
Okay, let me continue the rest of the project. MKP is nothing but a matrix keypad, and we can see the circuit diagram of the MKP. And yeah, CLO is the keypad in which a number of tackle switches are connected in a row and column concept. And COL2 and COLL, this is used when more number of user inputs are required and still want to save more controller input and output lines. And these keypads are most commonly used in telephones and digital lockers, etc. Then ISR. ISR is nothing but an interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. It must be terminated with the instruction RETIE. ISR attends to the request of interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. When interrupt occurs, the MPU completes the instruction being executed. That is, that it disables global interrupt enable and places the address from the program counter on the stack. Then let me jump into the next topic, interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then MPU or MCU acknowledges the request and attends to the request and goes back to the processing where it was got interrupted polling. Interrupts is the process where the computer or controlling device waits for an external device to check the read lines or state, often with low level on. And the next topic is timers. Timer is an important application in an embedded system, which is default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating delays. And timer or a counter is a software designed to count the time intervals between the events. Resolution, which is also called as a register with 8 or 16 bit, and tick is referred as the change from one number to the another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or a post-scalar. Modes of timers are counter, PWM, or a pulse generator, etc. And that's the end of our PPT presentation. And let me explain about the PicSimlab working. This is the default time, and this is the status of the car, and this is the current speed 0. And to increase the speed, we use the potentiometer. See, we are increasing the potentiometer now. Uh, gradually increasing. Yes, yes, it's gradually increasing. To change the gears, we use this switch as input. Neutral gear, gear 1, and gear 2, and gear 3, and so on. And then after setting the gears, we use file reload text, and we also use RB3, RB4, and RB5 switches to control this. And we now executed and file reload test, and I am changing the speed and then the gears. And to access the menu, press RB3 switch and then enter the password. And to enter the password is 4-digit password, and and if the user did not enter the password for 5 seconds, it's automatically dispatched. To enter the correct password, and this is the menu. To access the menu, we use RB4 and clear log and change password. If you wish to clear log and change the password, and wave log and clear log will display, and we can change the events performed earlier. To watch the events earlier performed, select for RB5. See the events. First, we changed the speed, next gear neutral, and so on. And gear at 43, gear at 43, gear at neutral, and gear 3 at 43, and speed, and so on. To go back to next, press R3 and R5 and RAS. And I'm changing the speed again, and change of the gears and speed again. And to after changing the speed, and we can go to the clear log by entering the password, wave log and clear log, and log cleared successfully. Wait a minute, it will logs cleared successfully. Now we can see the log is cleared successfully, and represents no logs. And there is a no logs cleared successfully. Then reload text, and then we can see the microcontroller PIC 16587 microcontroller. The code is written and saved here. And next, open the MPLAB XIDE to see how the code operates. MPLAB XIDE is used to write the embedded C programming code. Nothing but to write a bare metal programming. It takes some time to open this file. Wait for a second. And this praising a car black box our project. Yes, opened. Then we can see some source files, linker files, and libraries. Let me open the source files. ADC and car black box, and I2C and ISR and main.c. Main.c is the main program, and we have to include some header files like .h, and these are the connections we have done in PIC 1658 F8 and 77A microcontroller. And these are the place for header files. These are the place for the header files to define some macros. And this is the I2C module, and this is the timer module. We can see the code written. Like this, we can create variable .c and .h files. Uh, then in MPLAB XIDE, and we can use XC at a compiler to compile this program. Let me compile the program. It's loading, and build the project, and the loading is successful. And this is how the MPLAB XIDE works, and the project is successfully completed. And this is the working of black box project.